In this video, we will discuss about types of sets, empty sets and equal sets. If you want to learn the basics of sets, then click on the link in the I button. So let's start today's topic. There are two types of sets. First one is finite set. As the name suggests, this set has finite number of elements in it. That is, we can count the number of elements. If the number of elements is uncountable or infinite, then it is called an infinite set. Let us consider a set of factors of 6. It is equal to 1, 2, 3, 6 in roster form. We can count the number of elements in this, so it is a finite set. Similarly, if we take a set of all the months of a year, it is a finite set. But if we take a set of multiples of 2, then we have 2, 4, 6 and so on. So clearly it is not a finite set. Now what if a set has no elements at all? Is this possible? Yes, such sets also exist and they are called empty set. The empty set is the set which does not contain any elements. It is also called null set or void set. The empty set is denoted by the symbol phi or empty brackets. Phi is a letter of the Greek alphabet just like alpha, beta, gamma. To understand the empty set, let us consider the example. A is a set of all x such that x belongs to n and x is less than equal to 0. Which natural numbers belong to this set? Answer is none. All the natural numbers are greater than 0. So A is the empty set. As it has 0, that is countable elements, it is a finite set. Another example of void set is set of all x such that x belongs to q and x square minus 3 is equal to 0. This means x is a rational number which satisfies the equation x square minus 3 equal to 0. Let us find out the solution of this equation. X square is equal to 3 or x is equal to plus minus under root 3. So it has two solutions, root 3 and minus root 3. Both of them are not rational numbers. So B is equal to 5. So I hope you have understood all the three terms: empty set, finite set and infinite set. Next comes the term equal sets. Suppose I have two sets A and B. If every member of A is also a member of B and every member of B is also a member of A, then we say that the two sets are equal and we write it as A is equal to B. This clearly means that the two sets have exactly same elements which may have been written in different orders. Like if we take A equal to 1, 2, 3, 4 and B equal to 4, 3, 2, 1, then A is equal to B. But if C is equal to 2, 3, 4, then we can say that A is not equal to C, as C does not have the element 1. Similarly, if A is a set of all prime numbers less than 5 and B is a set of all the prime factors of 6, then A is equal to B because A is 2, 3 and B is also 2, 3. So if you know the roster form of a set, it is easy to compare the sets. But you should note few things here. Number 1, it is not always possible to represent every set in roster form. Some sets like the set of real numbers R cannot be written in roster form because the real numbers do not follow any pattern. Number 2, normally we don't repeat any element in the roster form, but even if there is a repetition, the set does not change. Like if A is equal to 1, 2, 3 and B is equal to 1, 2, 2, 3, 3, 3, then we will say that A is equal to B because they have the same distinct elements. So now let us discuss the exercise 1.2 based on these concepts. To decide the answer to question 1, we will change the descriptive form to the roster form as it becomes easy to count the members. So the first one is an empty set because no odd natural number is divisible by 2. 2 is the only even prime number, so the second set is not an empty set. In third case, we have to find a natural number which is less than 5 and at the same time greater than 7. But this is not possible. So this set is empty. two parallel lines never meet and so they cannot have any point in common. So the fourth set is also the null set. I think you can solve the second question easily. So please try it and then cross-check your answers. So the second and fourth sets here are infinite, while all other sets have finite number of elements. In question 3, first set is infinite, as through every point on the y-axis I can draw a line parallel to x-axis, and so we have infinitely many such lines. The second one is clearly a finite set. In the third set we have to take multiples of 5, which are 5, 10, 15 and so on. So it is clearly an infinite set. If we talk about the fourth part, it is a finite set, though it is not possible to count the number of animals present in this world, but it is definitely a natural number. This number keeps changing with time, but still it is a finite set. It is not never ending. We know that infinitely many circles can pass through a given point, so the fifth one is an infinite set. Moving on, in fourth question, we have to identify equal sets. We need to consider the roster forms of the sets in order to compare them. So please try these. As you may have noticed, first one are equal sets. In the second part, one of the elements is different, so we write A not equal to B. In third part, B is a set of all possible even integers less than equal to 10, so B is equal to 2, 4, 6, 8, 10, and hence A is equal to B. In the fourth part, A is a multiple of 10. Are all the members of B multiples of 10? No, 15, 25, etc. are not. So this implies that A is not equal to B. Question 5 is also similar. In first part, what would be the members of B? Solution of x square plus 5x plus 6 equal to 0 is given by splitting the middle term. So we have x plus 2 into x plus 3 equal to 0, which means B is equal to minus 2 comma minus 3. So clearly A is not equal to B. In the second part, the distinct elements of both the sets are F, O, L and W, and so they are equal sets. Now quickly select the equal sets from the given group of sets. Observing carefully, you will find that we have only two pairs of equal sets here, that is B equal to D and E equal to G. Children, with this we come to the end of this video. Hope you enjoyed this session. We will meet again soon with another session on sets. If you have any queries, please leave your question in the comment box. Take care and goodbye.